Hi everyone and welcome to our IMAX from 5 to 2 differentiation. This is quite hard and because these notes, because this chapter is quite long, so we're gonna do three different parts. So first part we will move from the beginning. You need to know what is the relationship between one limit and relation to the differentiation. Differentiation is one of the topic for calculus. It's the one that is a very advanced level because you're taking a maths, and this chapter is already go in the advanced level and compare with students who didn't take maths as their subject and they will don't know about it. So differentiation is important because when you move to Form 6 and also for matriculation, you use for it for your further study. If you carry on to your further study, then you learn more about differentiation. Now our syllabus just stop at the basic. More things you need to know when you move to another study like Form 6, A-level or other college like matriculation or after that. So now differentiation has a relationship between limit. So in limit, if you learn function in Form 4, when you want to do the reciprocal function, the denominator cannot equal to the number in the denominator. For example, x cannot equal to 3. This one, if you put x equal to 3, so you put 3 inside, 3 minus 3 0, then you cannot do the answer, will be undefined. But differentiation tells you there is a limit to calculate the function, the equation of the function. When we want to say when x is 0.1, I substitute this number inside the equation, so I can get the answer is 3.1. So I plot. You try to plot all the graph here, then you will realize when x approaches to a means menghampiri a, but x cannot be equal to a, then we can say that the limit of fx when x approaches to 0, x squared plus 3x over x is 3. Why? If you try, if I put fx, when fx equals to 3, what will happen? I put all the 3, you realize all the number become 0, so you cannot calculate. You cannot calculate answer, so it will be undefined. So you can say that x approaches to a, but not x equals to a. X not equal to a. This is, you need to know limits. So when you want to do question about limits, you need to know how to determine limit of a function. For example, to find a limit value of a function fx, we just need to substitute x equal to a. When we do if fa is not equal to 0 over 0. Just now, for example, now f function is like this. The denominator, and also the up and down, if when you substitute the number inside, you get 0 over 0. Then you cannot do. But when it's not equal to 0 over 0, then you just substitute it. Just sub it in the equation, so you get the answer. Limit when x approaches to a, fx equals to fa. Just make the answer like this. Okay. But if fa equals to 0 over 0, when you calculate, you realize, oh, I can't calculate the answer. So what you do? You can make the fx either doing factorization, rationalize the numerator or the denominator of the function. Okay, let's see one question. Okay, this is for the Basel function. Okay, let's see one question to let you understand. Today, okay, determine the limit of the function. We see the number A. When limit x approaches to 0, okay, 3x minus 1. What is the limit for the equation? Okay, we go for the answer. Okay, you see, when I substitute x equals to 0 inside the equation, so 3 times 0 is 0, 0 minus 1 is negative 1. So this equation is the answer is acceptable and it's not equal to 0 over 0. You get the answer like this. But in one cases, if I cannot get the answer, I get the answer in 0 over 0. What we do? Let's see example C. Okay, x squared plus x minus 6, x plus 3. Okay, when you try to do the question, okay, you sub it in the equation if the denominator, or you can say that the numerator, when you sub it, if you get the answer is 0 over 0, for example this question, it's actually 0 over 0, so you can't do the question. What you do? You make the numerator become like this. You do factorization to factor out this, become like this. So you can cancel out one of the equation, one of the expression here. So you can just potong, and you get this one, and you sub inside the x equals to 3, and you get the answer negative 5. So here you have 1 mark for the step, and you write this one, you have another 1 mark, and you sub it, earn another 1 mark, answer 1 mark. This is how the limit going on. Now, it's quite new for you, this one. Okay, it's actually work like this. Because now, we already know limit. Okay, so using first principles to find the first derivative of a function, I give you a graph, a curve. Okay, the curve, and I draw a line. The line I call as a tangent. Okay, using curve to find gradient is not accurate, and it's very hard to find answer. So I make the curve. I make a line at the equation, the curve, and I will plot the point here because it intersect together. So I will get here. I can say that it is xy, and I plot another point here that is far away from the point. So I can find the gradient of the equation of the line, this line. Okay, what is the gradient for this line? Okay, you see, okay, it is x, is y. So when this distance, this horizontal distance is delta x. delta is just a representation. For those who are in UEC, your delta x is a capital letter, not small letter, capital letter. But actually it's the same thing. So this is delta x. Okay. So I can say that this is x. So go to here is x plus delta x. Okay. From here to here, the distance here is delta y. Delta is a representation, okay, for a number, okay, and assume this is nothing, just kosong kan, nothing, okay. So here is y. So go to here is y plus delta y, and I put the coordinate for this one. I plug inside. So a equals to xy and t is x delta x, y delta y. So from the point A, I will get this equation, and from t, I will get another equation here. X plus delta y, because I just sub it from the equation 1. Okay, then I do the expansion. Okay, I make the x delta x and then square. I expand it to become a simplest form, like this. Okay, and then I do the elimination method. 2 minus 1, I will get delta y equals to 2x delta x plus delta x squared. Remember, this is a delta x squared. Okay, delta is a number. It's a same characteristic as 2, but it's different. Okay, means same characteristic, but I just use another thing to represent it. So this thing, because here got delta x, here also got delta x, so I can divide it by delta x. So delta y over delta x equals to 2x plus delta x. So delta y delta x also same as the gradient. So I can come up with a new equation. Limit when delta x approaches to 0 means delta x cannot, when delta x equals to 0 means the limit is cannot, the limit is like that only. Okay, so because here I got delta y delta x, so I just sub inside limit, okay, 2x plus delta x. When delta x approaches to 0, I sub, okay, delta x equals to 0 in the equation, so I can get answer. The limit is 2x. So 2x, when I put inside the equation, it becomes 0. So the limit is until 2x. When delta x equals to 2x, so the whole equation will become kosong. So just because I say that the gradient of the AT is delta y over delta x, so I can say that dy over dx is 2x. Why? Because we use the dy dx to represent that limit del y or del x is, okay, like this. Okay, del y del x limit when del x approaches to 0, so dy dx equals to limit del y over del x when del x approaches to 0. Okay, we try to do a question here. Okay, try to do a question from here. Okay, let me see the question. Where is the question? Okay, yes, this one. Okay, find dy dx by using first principle of for each the following y equals to fx. Because here we say that this is y equals to fx, so what you can do, we do the a question. Okay, now I try to do by myself. Okay, so now, okay, I make the y plus delta y. Wait, okay, the answer will go like this. Okay, y equals to x. Okay, we try to see the answer. But now my mouse is not working. Okay. I sub the y become delta y. Here I put x plus delta x minus with x, so I get delta x. Okay. Then, okay, delta y over delta x equals to 1. So I can say that dy over dx is limit of this one, so I will get 1. Okay. Because this is because this one actually is it's a one variable. So when I do the first derivative, I will get 1 only. Because this one is not a curve, it's a line. It's a line, means so when I put any point there, it's not useful. It's not useful. So I can get the gradient is 1. This one, because we know about y equals to ml plus c. It's actually same thing as here, but we're doing another form. Okay. Okay. We just do like this. Okay. So it become like this one. Because I say that y equals to 5x, so this one I make that this. Okay, because y equals to 5x, so delta y plus 5x equals to 5. Okay, the x I sub it become x plus delta x. I move the 5x from here to here to minus it, and 5x I expect it to become 5x plus 5 delta x minus 5x. So I cancel out all these two, become 5 delta x. I divide, I will get answer delta y over delta x is 5. Then I do the dy dx. Actually, dy dx is called as gradient of the function. Okay, gradient of the function means gradient of a tangent. Sorry, gradient of a tangent. So this one can carry out, so get 5. So here you got another 1 mark here. This is how the thing going on. So that is our first part of the uh, this chapter. We will see in the next part of this chapter. Goodbye.